Hey everyone, my name is Rob. I've been working with the GraphQL working group on the defer and stream directive, and I'm going to talk about that today. So first about me, I work for 1stDibs. It's an online marketplace for high-end furniture, fashion, art, jewelry. There's a lot of cool stuff there. You should check it out. And our stack is based on GraphQL, React, and Relay. We've been using GraphQL Relay in production for a while now. I think we started in 2015. So today I'm going to talk about defer and stream. So what is defer and stream? Why do we need it? Why has the GraphQL working group and myself spent this time developing this? How can you use it in your queries? I'm going to go over in depth what the response to GraphQL queries containing defer or stream look like in our current spec draft. And then we're going to explore some of the features that you get with this response format. So what is the problem that we're trying to solve? GraphQL is great at taking all your application's data requirements and making a single request to the server. And it's right on the GraphQL homepage. This is a major feature. You can get many resources in a single request. But this could also be a drawback. It means you don't get any results until your entire query is ready. Even if most of your query's data is really fast, just one piece of data that's slow is going to slow down your entire request. And so defer and stream are meant to address this. It lets you deprioritize some parts that may be less important in order to lower latency of the most important parts of your query. So defer and stream, they're directives for GraphQL, and you can use them to tell the server which data can be incrementally delivered. So that means that all of the data that's not incrementally delivered can be returned and rendered sooner by your client. So we use defer to incrementally deliver data inside GraphQL fragments, and stream is used to incrementally deliver items from a list field. So here's an example of what it looks like when you're using defer and stream. So on the right, the deferred parts of the data are loaded in when they're ready. But on the left, you don't see any data until the entire query has loaded. So adding defer and stream, you'll now get multiple GraphQL payloads streamed to the client instead of one single payload. And the client can render results from the initial response while the rest of the data is still loading. There are other options that you could use instead of defer or stream. You could use multiple queries. You could split up your requests and send multiple queries to your server. There's some downsides with that. There's work on the client to coordinate each of these requests and responses. There's overhead just from having multiple network round trips. And a lot of times, your downstream queries depend on data from your upstream queries. So you can't start your second query until you got some data, IDs or something back from the first query. Also going to say, how does defer and stream compare to subscriptions? Because subscriptions are another way of delivering multiple results from GraphQL servers. But subscriptions, the intention there is to allow servers to deliver real-time events to clients, while defer and stream, we're focusing on lowering latency of essential data. And the idea isn't to make your query take longer, but it lets you get the most important results sooner. So, and with defer and stream, we can use short-lived HTTP connection. We don't need to use WebSockets, any other stateful kind of connection that you need for subscriptions. So going back to the history, defer and stream, it's been talked about for a long time. Lee Byron did a talk way back 2016, and his talk was about a few different ideas for new features for GraphQL. Defer and stream were in there. And when I saw that, I was interested in defer and stream. I saw how it could solve a lot of challenges we saw writing GraphQL at 1stDibs. But there wasn't really a lot of movement on it for a while. We heard that Facebook was experimenting with it internally. didn't really see anything happening outside of Facebook. We've been using Relay at 1stDibs. Following on GitHub, we started seeing support for defer and stream and Relay, but there weren't any GraphQL servers that had defer and stream, so couldn't really make use of it. So some of my colleagues and I, we started working on adding support to GraphQL.js so we could use it in production. And then since we did that, we started going to the GraphQL working group meetings and presenting it and trying to get defer and stream into the spec. And then since then, it's evolved quite a bit over the years. And that first version that we started, we basically just modeled after what we saw was built by Facebook internally. But then we identified some things, some areas for improvement there. And so last year, we came up with a new response format that addresses some of those areas for improvement, and been working on the implementation and the spec draft for all of that. And so now we're getting ready we want wider feedback from the GraphQL community. We haven't implemented in the latest GraphQL.js alpha. We'd love for people to start using it, experimenting, letting us know what works, what doesn't work. Yeah, so getting into the details, this is the definition of the defer directive. You could use it on inline fragments and fragment spreads. There's two arguments, if and label. And the if argument is just like the if argument that you have on the skip or include directive. But this case, it's telling you if it's true, or if you leave it off, since that's the default, the fragment, you're telling the server that it's OK to defer this fragment. And you could also pass in false, and it'll be as if the directive wasn't there. And this just lets you be able to control it with a query variable. Then the label argument is a string that you could pass in, and that string gets mirrored back in the response. So if you have multiple defers in your query, you can use the label to know which response corresponds to which defer. So here's an example query. The query that's loading the name and homeworld of our hero. And let's say that loading the homeworld is an expensive operation. So by deferring the homeworld fragment, we can get the hero's name while the homeworld is still loading. We just need to put the defer directive on the fragment spread. I'm going to look more closely at the response now. So first, you're going to get the initial payload. And this has the data. This is just like a normal GraphQL response. But the data that's deferred isn't in here. And there is a new object on this response pending. It's an array of objects. And this is telling the client that the server is working to deliver some data incrementally. So on this object, it has a unique ID. And you'll reference that later in other parts of the response. And there is also the path and label from the defer directive. So this is how your client knows that this is for whichever specific defer, based on the label and the path where it appeared. There's another field, has next, and this is going to appear on every payload for an incrementally delivered response, and it just simply lets you know that you should expect more payloads. All right, so now some amount of time has passed, and the server sends the second payload. And this payload has an incremental array. There's an ID and data property here. So the ID, you can match this up with the ID on the pending object and to know which deferred fragment this data corresponds to. And the client will know that this data belongs at the path that was in that same pending object. Then there's the completed array, and there's the ID here again from that same pending object. And this lets you know that all the fields that were deferred as part of that deferred fragment have been returned in the incremental array. And finally, there's has next false because everything's been returned. There's no more payloads coming. A lot of people ask us if you can put defer just on a field, and we decided not to allow this in the spec. If you do want to defer only one field, you could wrap it in an inline fragment, like in that second example. And our expectation is that GraphQL fragments are going to be associated with a UI component, and a deferred fragment is a good fit for a UI component that's going to be loaded in asynchronously. And we found in practice that it's rare to only need one field for these components. Usually, it's a component that needs a bunch of fields, and you want them all to arrive at the same time. And when that's ready, that's when you can render that component. So yeah, so you want to group all the fields for that component into a single deferred fragment. They're all going to be returned together, and then you can render your component without having to manage loading states of each individual field. For the stream directive, you can use it on list fields, and you'll get some items from the list while the rest are loading. So just like defer, you have the if argument and label argument. That works the same way. And then there's the initial count argument. And that's the number of list items the server will return as part of the initial payload. This is useful. You have something where there's some data above the fold. You want that stuff right away. Later items that you have to scroll to see, or then those are, you can let them come in later. Yeah, so in this example, we're asking for a list of films, and we want the first one to be returned in the initial payload. So we have initial count 1, and the remainder of them are going to be streamed. So we have the first payload, and the first film is there, and then there's 2 more payloads with each film. In that initial payload, again, it's just data, just like a regular GraphQL response. And that films field is incomplete. And you know that it's incomplete because you have the pending object. The path points to where that field is in the response. And you have the label, so you know that it's from that stream that had the label there. And then you have has next true because we're expecting more payloads. And then in the second payload, we have the incremental object again, and it has an ID of 0, so we know that it corresponds to that pending object. We know that the path for this item is the same path that was in the pending with ID 0. And the item that's returned here, it's meant for clients to append it to that list. In the third payload, it's the same thing again. Now you get the third list item, and this is the final list item, so there's also completed here. So now you know that the list is complete and has next is false, so you know that there isn't anything else in this query that's being delivered incrementally. Yeah, so take a step back a little bit, how we came up with this response format. If you tried out defer and stream over the past few years, or if you saw one of my other talks about it, things are a little different now. So I'm going to spend some time showing how it evolved. And yeah, so the first algorithm that we did for defer was what we called like forking execution. And basically, as you would encounter a defer on a fragment, you would basically take all the fields under there and start executing them separately. So in this case, in the first deferred payload, we expect to get the home world with the name and terrain. And in the second deferred payload, there's the person's first and last name and the home world and its name. And so there's overlap. So the person's first name is in both the initial payload and the second deferred fragment, and the home world's name is in the 2 deferred fragments. And if you weren't using defer, when GraphQL executed this, it would gather the selection sets and only execute each field once. But if you're forking the whole execution when you encounter the defer, then you could have fields that are being executed and returned more than once. So here's the response. And so you can see the duplication. And this is like a contrived example. It's very easy to just look at this query and rewrite it, so it's not the case. But imagine if you're using a framework like Relay. You have fragments that are corresponding to all your UI components. The whole thing is built by the compiler into a single large query. You could very easily get into a situation where you have a lot of data that's duplicated because it's in deferred queries and non-deferred queries, overlapping fragments. And yeah, here's another example. So in this query, there's a whole bunch of defers. They all have a different label. Each one has a unique field on it, but then they all have this bio field. And if you weren't using defer, it would kind of just be equivalent to this. Every field is here once, even though bio is in all the different fragments. But if you were forking your execution, and you could have really large responses. So that bio field would be executed and returned to the client many times. Maybe it's like a really expensive field. It's generated by an LLM or something. And it's an opportunity for a denial of service attack on your GraphQL server because it gives you a really easy way to generate very large responses. And it could be even worse, exponentially worse, if the defer was nested under a list field, where now you're doing this for lists, list of lists, et cetera. So we discussed these issues a lot, decided to explore some different options that wouldn't encounter this problem. We looked into some algorithms that could detect duplication in the response and filter it out before sending it to the clients. And this would reduce the payload size, but your server would still be doing extra work of executing the fields multiple times. We looked into adding some kind of cache on the server to make sure that fields aren't executed multiple times. But now you have memory overhead of a cache. You have to manage that cache. And we looked at algorithms that did query planning, so basically a step before execution, where you analyze all the fields and find a way to optimize it. GraphQL doesn't have, the spec doesn't have any query planning now, and we didn't want to start requiring that, so we didn't go down that path. And then we ended up with this new response format and an algorithm that was designed to not duplicate any execution from the start. So here's the same example, except with the new response format. You have your bio field returned once, and you have all the other fields are sent in, no duplication. And basically, the collect fields algorithm that prevents duplicate field execution is preserved, and everything's only getting sent once. So the way that it's implemented is when the GraphQL server collects fields, we have to take note of which field belongs in which set of deferred fragments. So the first step is to separate out fields that are in the initial payload, and then we make sure that they're not going to be included in any of the deferred executions. And then we make a group for each defer and include the fields that are only in that defer. And then we'll set up another group for every field based on what unique combination of defers the field is located in. So you have a group for the initial payload, a group for shared items between defers, and then you have groups for the fields that are only in a single defer. And so in the response here, we have two pending objects because there's two deferred fragments. And in the second payload, we have two groups of data. So because the homeworld's name was in both differs, that's going to be grouped separately from the terrain field, because that was only in one differ. And once that both of these are sent to the client, then that entire homeworld fragment can be considered complete, and you'll get the completed object in that payload. Then all that's left is the last name field, and that's returned in the third payload. And since the rest of the fields in the name and homeworld fragment were already delivered, we can mark this one as completed and send the completed object. And another important thing was that we wanted to make sure that the server's payloads were always actionable. So I mentioned how we expect all the fields in a deferred fragment to be returned together. And so in this example, the second payload is not actionable because none of the deferred fragments have all their fields. We have one bit of data, but it's not enough for any of the fragments to be considered complete. So it's your UI framework can't really do anything with this payload. It can't render any of the UI components that are associated with those fragments because they're all missing some amount of data. So our spec says that the servers should hold on to the incremental data until at least one deferred fragment has been fully completed. So there's a few more features that I want to walk through. And while defer and stream are great at reducing latency in your application, it's definitely possible to overdo it. Kuei talked about this yesterday. If you have a query with hundreds of deferred fragments, each time a payload's delivered and your UI is re-rendering, that frequent re-rendering will cause poor performance. And so this response format can help with that because we allow batching multiple defers into the same payload. So this is the same example from before, but this time we returned all the data for both deferred fragments in the second payload. And now the client code only needs to re-render the UI once. So the response format's flexible. Any number of defers can be completed in the same payload, and the completed array will always let you know which deferred fragments were completed, making it easy for your GraphQL framework to re-render the appropriate UI components. We also allow servers to completely ignore defer stream directives. We call it inlining. Maybe the data is cached on the server knows it can efficiently deliver the response without any delay. So the server, in this example, chose to inline the homeworld fragment. So its data is included in the initial payload. And when that does happen, the server is not going to send a pending object. So the client knows if a client was expecting something to be deferred and it doesn't see the pending, then it can assume that the data was inlined and it doesn't need to wait for the defer to complete. By having this pending and completed fields, you can track multiple streams in the same query. So in this query, we have two separate fields with different streams, different labels. In the first payload, we get two pending objects, so we know that there's two separate streams happening. In the second payload, we get the one remaining item from the film stream, and we get the completed object, so clients know that this stream is done. And in the third payload, we get the rest of the list items for the people stream, along with the completed object, so we know that now both streams have been completed. And in this response format, when we do send items for a stream, it's an array that lets the server send multiple list items in a single incremental object. So if you are delivering large lists, you can do that really efficiently by sending large batches of items, and your client won't have to re-render after each individual item. Another interesting scenario is asynchronous list completion. So stream directive is a good match on your server for asynchronous data sources. If you're writing JavaScript, we have async iterables, async generators. And the server can deliver each item to the client as soon as the asynchronous data source gives it off to the server. A lot of these asynchronous data sources also complete asynchronously. So that means the server won't immediately know if the last item produced is actually the last item until the data source sends a close signal or something like that. And so we can handle this with stream. So in this example, we received the last item in the list in the second payload. And this is the last item in the list, but the server doesn't know it yet. So the payload has the field has next set to true. Now, some time has passed, and the server does receive the close signal. It knows that that was actually the last field in the list. So we can send another payload that has the completed object with the ID. And now your client can know that it has the complete list. All right, last thing I'm going to talk about is error handling. So what happens if you encounter an error during execution of a deferred or streamed field? And for the most part, it's the same as a normal query. You get the same errors, but they're returned on the incremental object where the error occurred. But what about error bubbling? So in the GraphQL spec, if an error or a null is returned on a non-nullable field, that null should bubble up to the nearest nullable field. So in this example, the error should have bubbled all the way up to the hero field. This is a challenge because we can't go back in time and null out a field that was already sent. So instead, the incremental data for this entire defer is not going to be delivered. So we get the completed response with the errors that caused the defer to fail. And the fully resolved response is going to be similar to as if the deferred fragment was skipped. So we want to prioritize. We don't want a client to render some data and then take it away. So we decided that the defer fragment will fail. And yeah, so that's all I have. Hopefully, we went into the details on defer and stream and saw how we got to the point where we are. We have an incremental delivery working group that meets monthly, and there's a GitHub repo for that. There's also an incremental delivery working group channel on the GraphQL Discord. So if you've been using defer or stream, have any feedback, feel free, join a working group meeting. Let us know in the Discord channel or in GitHub or anywhere else. And yeah, thanks. We have time for 1 or 2 questions?
So if I'm using federated GraphQL and I'm using a router that supports the defer and stream directives, do all my subgraphs need to also be using servers that support those directives, or will the router suffice?
I think they probably would to be most efficient. I guess maybe the router could, I guess maybe if the defer boundary lines up where the federation happens, maybe the router could do something smart. But yeah.
So I know that a lot of the open source libraries already implemented the different stream directives. What's remaining like open issues until this gets officially be part of the spec?
Yeah, well, it was I've been working with the working group to come up with this response format, and it's been there's been a lot of work going to just get a spec draft that describes the algorithms for this new format. And yeah, we're at the point now that we want to start getting feedback on this implementation and what the spec looks like. So, because it's changed a lot, and it's definitely a bit more complicated than what the previous iteration was.
Thank you.
Yeah, I guess I have a question about the at stream specifically. I noticed that in the response format, we specifically did not include the index of the items delivered in the stream. I'm wondering if that's an intentional decision, and if so, what's the reason behind it?
Yeah, I guess we didn't want to. I guess for the scope of this, we weren't planning on supporting, I guess, like sparse list or out of order delivery. So the assumption was that each list item you get is going to be just appended to the previous the end of the list. I think that you could support that in the future if you did have an index. Like adding an index shouldn't be a breaking change, and it could be that if you have an index, that's where it is. But yeah.
I see. That makes sense. I was kind of thinking about a situation where a client might have like several processors, and each was handling one of the stream response, and it would be great at some point they need to merge together and have that index to reconstruct that ordering. But yeah, thanks for it.
Yeah.
Does it have any significant downside to make a single field can be deferred?
I think just for simplicity and consistency, there is some considerations because the path for the defer points to where the fields are being inserted. And so it kind of is like slightly different semantics if it's a field versus a object where you're spreading the fields in. So just for simplicity, we kept it on fragments.
If I sort of squint at the data protocol, I could see how something similar might be used for like a spec native continuation protocol for separate requests, essentially pagination or something like that, where you could issue a continuing request that would then like amend a previous request. Has there been any discussion of anything like that, or is everything focused on like the sort of single request defer and stream?
Yeah, I don't think that we've discussed that case, but I do think that like having this like opens up a lot of options for other kinds of future enhancements. Just any kind of way that you want to take some data and apply it to a previous request.
Hi. I see some overlap in the functionality in terms of what is returned and few other things. So I was wondering if there is an opportunity to combine those two directives into one.
Maybe. You mean like have one directive?
To support both stream and defer functionality.
Yeah, haven't really considered that, but I think I like that they're separate because there's stream, for example, has the initial count, and that wouldn't apply for defer. And I think it's just easy to with the descriptive names.
With stream, is the value that comes back, is it always just one item of the list at a time? Like you can't say, I want the first 5 and then I don't care, give me the rest, no matter how long it takes.
Yeah, it's not determined by the client. The client is only able to say how many it wants in the initial response. But the server has the ability to batch them however it sees fit.
Okay. Thanks.
All right. Yeah, thank you, everyone.